In the heart of Japan, where land is scarce and earthquakes are constant, entire buildings can do something most people would never believe. They move. Apartments, schools, historic temples, and even concrete office blocks have been lifted from the ground and shifted to new locations, sometimes hundreds of meters away, without a single crack in the walls. What looks impossible at first glance is actually a result of decades of engineering evolution, necessity, and a national determination to protect history, cities, and human life. How does Japan move entire buildings without breaking them? And why did the country develop this astonishing ability? Let's find out right now. Japan sits at the crossroads of four major tectonic plates. Earthquakes here are not rare events, they are part of daily life. Every year, Japan experiences more than 1,500 noticeable tremors, some small, some catastrophic. In 1995, the Great Hanshin earthquake struck Kobe, killing over 6,000 people and destroying thousands of buildings. The message was clear. Traditional construction methods were not enough. If Japan wanted to protect its cities, it needed engineering solutions powerful enough to outsmart the planet itself. Japan's response was not just to build stronger structures, but to rethink how buildings interact with the ground beneath them. And that idea led to a once unthinkable concept. If a building is in danger or needs relocation, why demolish it when you can simply move it? Today, Japan uses several advanced methods to relocate structures. The first is hydraulic lifting. Engineers begin by digging beneath the building to insert a network of steel beams that support the foundation. Once the weight is evenly distributed, hundreds of synchronized hydraulic jacks slowly raise the entire building, millimeter by millimeter. A large office block can weigh tens of thousands of tons, yet the hydraulic system is so precise that sensors monitor vibration, stress, and tilt 1,000 times per second. If the building leans even a few millimeters, the system automatically adjusts to keep everything perfectly level. Once the building is floating on steel beams, it must be transported. That's where industrial-grade rollers, or dollies, come in. These massive steel wheels, often arranged in rows, create a movable platform beneath the building. Workers then push the building forward using hydraulic rams, guiding it along a pre-constructed path. To an outside observer, the process looks surreal. A school or apartment block gliding across the ground as calmly as a ship sailing through still water. Yet everything is calculated with surgical precision. Before a single millimeter of movement happens, engineers digitally map soil density, building weight distribution, seismic risks, and underground utilities. Nothing is left to chance. One of Japan's most famous examples is the 400-year-old Kyogakuin school building in Fukushima. To prevent demolition during redevelopment, the entire two-story structure was lifted and shifted 70 meters on roller platforms. Not a single wall cracked, and students continued learning inside the same historical classroom, just in a new location. But Japan doesn't move buildings only for development. Earthquake survival is another major reason. Many structures, especially before the 1981 seismic code reforms, were not designed to handle modern quakes. Instead of dismantling them, Japan can reinforce the foundation while the building is suspended in the air. Base isolation pads are inserted, flexible rubber and steel layers that absorb seismic motion, allowing the building to sway gently rather than fracture. In older cities like Kyoto and Yokohama, dozens of historic buildings have been saved using this combined lift and reinforce approach, preserving heritage without sacrificing safety.
Another remarkable technique used in Japan is the slide rail system. After lifting a building, steel tracks are installed on the ground beneath it. The entire structure is then rolled sideways on Teflon-coated shoes, dramatically reducing friction. Once the building reaches its new position, the rollers are removed and the structure is lowered onto a newly reinforced foundation. Many schools, hospitals, and municipal offices have been relocated this way, sometimes moving more than 300 tons in a single night. Then, there are cases where buildings have been moved not only horizontally, but vertically. In Tokyo redevelopment projects, structures have been carefully lifted several meters higher to match new flood and tsunami safety standards. The difference before and after is nearly invisible, except that the building is now safer and more stable than it ever was before. Moving buildings in Japan is not just about technology. It reflects the country's relationship with land. Urban space is limited, and cities evolve rapidly. Expanding a road or train line doesn't have to mean erasing history. Preserving a temple doesn't require freezing a neighborhood in time. By being able to move entire structures, Japan balances development and tradition in ways that few nations can match. But this engineering miracle has its challenges. The process is incredibly expensive. Lifting and shifting a medium-sized building can cost millions of dollars and involve months of preparation. Detailed underground surveys are mandatory, and areas with weak soil cannot always support the lifting beams. Certain materials, like brittle concrete, require additional bracing to avoid cracking. And despite the precision, the work is risky. If sensors fail or loads shift unexpectedly, the building could tilt or fracture. For these reasons, only highly trained contractors with specialized equipment are licensed to perform such relocations in Japan.
Still, the results speak for themselves. When a Kyoto temple was moved to widen a road, not a single artifact inside needed removal. When a residential block in Kobe was shifted after earthquake reinforcement, residents moved back into their original apartments without even noticing the difference except for the view outside the window. And when historic government buildings in Tokyo were relocated, their original architecture, walls, and woodwork were preserved exactly as they were built decades earlier. Today, Japanese engineers are exploring automated building moving systems using real-time AI load balancing and advanced seismic modeling. If successful, future relocations may require fewer workers, complete faster, and handle structures even more massive than today. In a country where the ground beneath your feet can shift at any moment, mobility has become a form of resilience. Why destroy when you can preserve? Why rebuild when you can reinvent? Japan has shown the world that even buildings, symbols of permanence, can adapt, change, and move when needed. In a land shaped by earthquakes, engineering is not just construction. It is dialogue with the earth itself. So what do you think about Japan's ability to move entire buildings without breaking them? A triumph of precision engineering? A brilliant blend of old and new? Share your thoughts in the comments and stay tuned for more stories of engineering, innovation, and human ingenuity.